Alright, here we're going to look at deriving the distance formula from the Pythagorean theorem. Now, we've been using the Pythagorean theorem, and we know that a squared plus b squared is equal to c squared. Now, remembering that c is always across from the right angle. Okay, and it doesn't really matter which one we call a and which one b. But we've been using a for our change in y and b for our change in x. Alright, so let's look at this. We have a triangle on a coordinate plane, and so we're at 1 and we're at 7. So the distance between those, now we could count, and so we go 1, 2, 3, 4, 5, 6. Okay, so it's 6. Now we also know that we could do that by, if we didn't have to count. Now remember, distance is, or length is found by subtracting. So we take 7 minus 1, or we could do 1 minus 7, but we'd have to take the absolute value of it. So remember that subtracting 7 minus 1 is 6 and negative 6, but distance is always positive, so that's where we take the absolute value. And so that's how we get the distance. Now we have y1, y2, x1, x2. Now this is what we've been doing. We've been taking the difference in x and the change in x and the change in y. So what we do is we subtract the two endpoints, these pair, and so when we talk about horizontal, we're talking about the change in x. It really doesn't matter if it's x2 minus x1 or x1 minus x2, because you're taking the absolute value of it, and you would end up with the same answer. Same thing with the y's. It doesn't matter which way you subtract, but you would take the absolute value. So again, it's the change in y and the change of x. Now, using the Pythagorean theorem to find the length of the hypotenuse. Now this is what we've been doing. We would then square and go from there. So a squared plus b squared. Now what we're going to do is we're going to end up substituting in here so that we get a is equal to y2 minus y1, b is x2 minus x1. Now we've been doing this, we were substituting in numbers. So I'm going to go ahead and start writing this out by hand, and then I'll put it up here a little bit cleaner on the overhead on the PowerPoint. Now, so here's what we have. We're going to substitute these two things into this. So we end up with y2 minus y1, and we're going to square that, plus the x2 minus x1 squared is equal to c squared. Well, we really don't need the square, the absolute values, because we're squaring it anyway. So I'm going to go ahead and get rid of the absolute values, because we're going to square this, and we know that anything squared is positive. Okay, and then we're almost done here. Now remembering that to undo the squared, we take the square root of both sides, so we would take the square root of this. Okay, and so now what we end up with is y2 minus y1 squared plus x2 minus x1 squared is equal to c. Now that would be for this triangle, but with a distance formula, we usually denote this with d, so this would be changed to d. So this would be our distance formula. We'd have y2, and again, sometimes I think it's easier to think of this as the change in x. So it's just you subtract your y's, you subtract your x's, square them, add them together, and then you take the square root. All right, now I'm going to go through and talk through the PowerPoint. So this is what we did where we plugged them in. Now again, we're taking the square root, so we don't need the absolute values. Now they just flipped it, but with this, and then you change it to d. So that's our distance formula using the Pythagorean theorem. And again, we do not need the absolute value, so typically you won't see the absolute value written out here with this, because again, you're squaring it, so usually we use parentheses. Alright, so now using the distance formula, you'll need to pause the video, but using the distance formula, what I want you to do is find the distance between these 2 points. Alright, so what we would do here is take the change in y. So we got 9 minus 3. So those are our y values, 9 minus 3. Then our x value, so it's 1 minus 7. Okay, so we take those differences. And then we'll square both of them. Now remembering, be careful with the calculator. Sometimes, depending on how you enter the calculator, it won't make this positive. But anytime you have a negative number and you square it, or anytime you square any number, it's going to be positive. And so we end up with the square root of 72, and take the square root of it, and you get 8.485. So that would be the distance between these 2 points. Okay, and so with this, we've derived the distance formula from the Pythagorean theorem. So the distance formula is just another version of the Pythagorean theorem. So it's actually the same thing, it's just been rearranged.